This is lesson 7.3, similar triangles, starting on page 483. Number 1, determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So on number 1, since these two lines are parallel, we know that our alternate interior angles here are congruent and our alternate interior angles there are congruent. Therefore, we have two angles of one triangle congruent to two angles of another triangle, and the triangles would be similar by angle-angle similarity. So as I write the names, I want to make sure to go in the same corresponding order. So if I start with y here, y, x, z, then I need to start with v here, so v, w, z. So in number 3, we're doing the same thing. We want to see if the triangles are similar. So if they are similar, then their corresponding sides will be proportional. We have 4 over 6, which would simplify to 2/3. We have 8 over 12. That also simplifies to 2/3. And we have 5 over 8, which does not simplify any further. Therefore, the triangles are not similar because corresponding sides are not proportional. Number 5, in the figure, AB intersects segment DE at point C. Which additional information would be enough to prove that triangle ADC is similar to triangle BEC? So we can prove that the triangles are congruent either by angle-angle if we have two corresponding angles congruent, or side-side-side if all corresponding sides are proportional, or side-angle-side if we have two pair of corresponding sides proportional and the included angle congruent. So in part A, it says angle DAC, which is this angle, and ECB are congruent. Well, that would not make these two triangles similar. First of all, it's only one pair of corresponding angles congruent, and we would need two to use angle-angle. And also, those are not corresponding angles. So they're not corresponding because DAC would correspond to EBC because the order of the letters would be the same there. DAC and EBC. So it's not A. B says AC and BC are congruent. So if AC and BC are congruent, then they would be in a 1-to-1 ratio. So we'd also need to know that these other sides are congruent, that they're in a 1-to-1 ratio. But we don't know that. So it's not B. C says AD and EB are parallel. So if these two lines are parallel, then our alternate interior angles here and here would be congruent. And therefore the triangles are congruent by angle-angle. We have two pair of corresponding angles congruent. So it is C, in fact. Number 7, identify the similar triangles and find each measure. And we're asked to find VS, which we're calling X. So our similar triangles would be the entire triangle, which is QVS, and that would correspond to this smaller triangle inside of it, RTS. Okay, now based off of our corresponding parts, we can set up a proportion. So QV corresponds to RT, and QV is the side of the larger triangle, RT is the side of the smaller, so now we need another side of the larger triangle, so that would be this entire side right here, VS, which we're calling X, as it corresponds to 12 of the smaller triangle. And from here we would cross multiply and divide, so 5 times 12 is 60, equals 3x, and divide by 3, and x is equal to 20, and therefore x represents what we wanted to find, VS, so VS is 20. Determine whether the triangles are similar. If so, write a similarity statement. If not, what would be sufficient to prove the triangles are similar, and explain your reasoning. So, based off the information that we have here, we have all of the side lengths, so we want to see if our corresponding sides are proportional. So we'll start with the smaller triangle, so this side right here, UY, as it corresponds to the larger triangle. So common mistake is to put 5 over 2, but 2 is only part of a side of this larger triangle. The entire side would be 5 plus 2, or 7. So we have this proportion, or this ratio, and we want to see if the other corresponding sides are in this same ratio. So then a side of the smaller triangle would be 10, and its corresponding side of the larger triangle is 14, and if we divide those both by 2, once again we get 5 over 7. So we have one more pair of corresponding sides to check. So a side of the smaller triangle is 8, and of the larger triangle would be this entire side, not just 3.2, but 8 plus 3.2, which would be 11.2. And if I multiply them both by 10 to clear out the decimal, I get 80 over 112. And then I can just start simplifying this. So if I divide by 2 and divide by 2 again, and then I notice these are both divisible by 4, I once again get 5 over 7. So all the corresponding sides are proportional, which means that the two triangles are similar by side, side, side. So we just need a similarity statement. So triangle UWY is similar to triangle UXY or UXZ, and that's by side, side, side similarity. Once again, on 11, we want to determine whether the triangles are similar, and if so, write a similarity statement, and if not, we want to state what would be sufficient to prove the triangles are similar and explain our reasoning. So, in these two triangles, we notice that we have two pair of corresponding sides given. So in the larger triangle, we have 10, and in the smaller triangle, that corresponds to 6, which we can simplify, divide them both by 2, and we get 5/3. Then in the larger triangle, we have this entire side, which is 6 plus 9, or 15, and it corresponds to just this part of the smaller triangle, so 15 over 9. And if we divide those both by 3, we get 5/3 again. So we just need to check if the included angle is congruent. So we have this side and this side, which means that our included angle is where those two sides meet is 38. And we have this side, and once again, where those two sides meet is 38. So the included angle is congruent, which means that these two triangles are similar, by side angle side. And careful to put those in the same corresponding order. So that would be FDB. Okay, once again on number 11, determine whether the triangles are similar. If so, write a similarity statement. If not, what would be sufficient to prove the triangles are similar, and explain your reasoning. So we have a 62-degree angle here and here, and we know the sides around that 62-degree angle for this triangle, but we only know one of those sides for this triangle. So we can't use side angle side, we can't test for that. And since we only have one pair of corresponding congruent angles, we can't use angle angle, and we cannot use side 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 because we don't know all three sides of each triangle. So this would be no, there's not enough information. And from there, it says what would be sufficient to prove the triangles are similar. So if we look at the sides that we do have, so we could compare this side to this side right here. So 2 is to 12. And that would simplify to 1/6. So then we have this side, but we're missing this side right here. So we also want that to be a ratio of 1/6. So a sixth of 18, 18 divided by 6 would be 3. So if this side is 3, then its corresponding side is 18. That also simplifies to 1/6. And then finally, the side opposite from 62 is 4 here, and the side opposite from 62 we don't know in this one. So we'd also need to know this side. So this time we have 4 over x, or wy, and we want that to be equal to 1/6. So if we take 4 times 6, we get 24. Which once again divide them both by 4, and it simplifies to 1/6. So once again, there's not enough information, but if JH is 3 and WY is 24, then we could say that triangle HJK, and careful that we put this in the same corresponding order. So I'm starting with H here, and that is my middle length side going to the angle of 62. So my middle length side is 18 going to my angle of 62. So I want to start, so if I start with H, then J, then K, then I want to start with W, X, Y. So if JH is 3 and WY is 24, then triangle HJK is similar to triangle WXY by side-side-side similarity. And number 15, when we look at an object, it is projected on the retina through the pupil. The distances from the pupil to the top and bottom of the object are congruent, and the distances from the pupil to the top and bottom of the image on the retina are congruent. Are the triangles formed between the object and the pupil and the object in the image similar? Explain your reasoning. So first off, we know that our vertical angles are congruent. So that's one pair of corresponding angles that are congruent. And it says that back here, the distances from the pupil to the top and bottom of the object are congruent. So these two sides are congruent. And the distances from the pupil to the top and the bottom of the image are congruent. So those two distances are congruent. So basically what we have here, let's just say that this has a length of 2, and this a length of 2, and this a length of 1, and this a length of 1. So in both cases, we would have 2 to 1 ratio, 2 to 1 ratio. So the lengths there aren't the important part. The important part is that these two sides are congruent and these two sides are congruent, which means that our corresponding sides are in the same ratio. So we can say that AB is congruent to EB, and CB is congruent to DB, so that means that the ratio of AB to CB will be equal to the ratio of EB to DB. And we also know that angle ABE and CBD are congruent because vertical angles are congruent. Therefore, we can say that the two triangles are similar by side angle side similarity. For number 17, we want to identify the similar triangles and find each measure. So we would have triangle QRS is similar to triangle QPT. So based off of the sides that we were given X is here, so X in the smaller triangle corresponds to, so this side of the smaller triangle corresponds to this entire side of the larger triangle, so that would be 20, so X over 20 is equal to, then we need a side of the smaller triangle, which is 12, as it corresponds to 16 of the larger triangle. So I'm going to go ahead and simplify right here first. So divide them both by 4. We get 3/4. Then we can cross multiply and divide. So we would take 4 times x is equal to 3 times 20 and then divide both sides by 4. So x is equal to 15, but we are asked to find st. So st is here. The entire length is 20, so if we take 20 minus x, or 20 minus 15, that would be our answer for st, 20 minus x. 20 minus 15 gives us 5 for st. For 19, we want to find hj and hk. So first identify the similar triangle. So we have triangle JHK. And I'm going from 1 mark, 2 marks, no mark. So do the same thing in the other triangle, 1 mark, 2 marks, no mark. So that would be QNP. And then we can set up our proportion to solve for x. So we have 4x plus 7 of this triangle, and that's the side in between the two marked angles. So that corresponds to this side, 12. And then we have 25, and that's the side in between 1 mark and no mark, 1 mark and no mark, so that's 20. Then we can simplify this, so divide them both by 5, and we get 5/4. Then we can cross multiply, so we would take 4 times the quantity 4x plus 7, and set that equal to 5 times 12, and distribute. And then subtract 28. And divide by 16. So x is equal to 2. Then we'll substitute that in for hj and hk. So for hj, we would have 4 times 2 plus 7. And 8 plus 7 gives us 15. And for hk, we would have 6 times 2 minus 2. So that would be 12 minus 2, which is 10. So for 21, to find GD and DH, we need to solve for x, and it's kind of tricky here. This mark means this entire angle, so GHJ. So actually, inside of this triangle, GHD is not marked. So, with that said, we can say that triangle GHD is similar to, so that would be 2 marks, and this is actually not marked, so no mark, 1 mark. So then we would want, inside of this larger triangle, 2 marks, no mark, and then this entire angle is 1 mark, so that would be GJH. And now we can set up our proportions. So we have this side of the smaller triangle, so 2x minus 2. And that would correspond to, so that is going from, that's the side in between the double marked and the single marked angle. So inside of the larger triangle, the side between the double marked and the single marked angle would be right here, 7. Then we need another side, so we can say inside of the smaller triangle, 2x plus 4. And that's the side in between the single mark, and remember there's actually no mark inside of the smaller triangle here, so single mark and no mark. So inside of the larger triangle, single mark and no mark would be this side, 10. From there we cross multiply, so we take 10 times the quantity 2x minus 2. And set that equal to 7 times the quantity 2x plus 4. And distribute. And distribute here. Next, we would subtract 14x from both sides. And add 20 to both sides. And divide both sides by 6. So x is equal to 8. We can substitute that back in to find GD. So GD is 2 times 8 minus 2. Or 16 minus 2. Which is 14, and DH would be 2 times 8 plus 4. Or 16 plus 4, which is 20. On number 23, we'll need a diagram. Okay, so when Alonzo, who is 5'11", stands next to a basketball goal, so this would be our basketball goal, which we don't know the height of. His shadow is 2 feet long. So it's casting a shadow here, which is 2 feet. And the basketball goal shadow is 4 feet 4 inches long. So it's casting a shadow this length. About how tall is the basketball goal? So once again, we're solving for x, and we have similar triangles here. So we can set up a proportion. So we have x of the larger triangle as it corresponds to, in the smaller triangle, 5'11". And then another side of the larger triangle would be this length, 4'4", as it corresponds to this side of the smaller triangle, 2. Now, I don't want to work with feet and inches, so I'm going to convert all these to inches. So I would get x over, so 5 times 12 plus 11 would be 71 inches. And 4 times 12 plus 4 would be 52. And 2 times 12 is 24. Now, I can simplify this ratio. If I divide them both by 4, I would have 13 over 6. And now I'm ready to cross multiply. So I would take 6 times x and set that equal to 13 times 71. Then if I divide by 6, I get x is approximately 153.8. So this would be in inches. So to convert back to feet, I need to divide by 12, and I get approximately 12.8 feet. So the basketball goal is approximately 12.8 feet tall. In number 27, we are given that triangle XYZ and ABC are right triangles. XY over AB is equal to YZ over BC. So those corresponding sides are congruent. And we want to prove that the two triangles are similar. So we already know that our corresponding sides here and corresponding sides here are congruent. And we know that these are right angles, which have to be congruent. Therefore, the triangles would be congruent by side angle side similarity. So we would state first off that triangle XYZ and ABC are right triangles. And I think I'm going to run out of room here, so let me fix this. So we know that triangle XYZ and ABC are right triangles, and that is given. Therefore, if they are right triangles, angles Y and B are right angles. And that's by definition of a right triangle. And if Y and B are right angles, we can say that they're congruent because all right angles are congruent. And we're also given that XY over AB is equal to YZ over BC. And so that's enough information to say that the triangles are similar by side angle side similarity. On 29, when Luis's dad threw a bounce pass to him, the angles formed by the basketball's path were congruent. The ball landed 2/3 of the way between them before it bounced back up. If Luis's dad released the ball 40 inches above the floor, at what height did Luis catch the ball? So we can call that X. And we know that these two triangles are similar by angle because we have two corresponding angles congruent. So if the ball landed 2/3 of the way between them before it bounces back up. So if this is 2/3, this would be 1/3, and so the length really doesn't matter. So if I call the entire length 60 inches, then 2/3 of that would be 40, and 1/3 would be 20. So 2/3 of 60 is 40, 1/3, or 60 divided by 3 is 20. So based off, that's probably the most difficult part to this problem, is figuring out what numbers to put here. Something else, you could probably even make that more simple. If this, let's say this entire length is 3 feet. Sorry, I was interrupted, so I had to stop and come back. So I believe I was saying if this entire length is 3 feet, then 2/3 of that way, of that distance, 2/3 of the way, would be 2 feet. Leaving me with 1/3 of the way is 1 foot, because 2 plus 1 is 3. So we have 2 out of the entire length 3, and 1 out of the entire length 3. So 2/3, 1/3. So that makes it more simple. Then we can set up a proportion to solve for x. So we have 2 of the larger triangle is to 1 of the smaller triangle, as 40 of the larger triangle is to x of the smaller triangle. So when we cross multiply, we get 2x is equal to 40. And if we divide by 2, x is equal to 20 inches. Number 35, certain medical treatments involve laser beams that contact and penetrate the skin, forming similar triangles. Refer to the diagram. How far apart should the laser sources be placed to ensure that the areas treated by each source do not overlap? So we have similar triangles here, this large triangle, and then inside of it, the overlapping smaller triangle. So we know the height of the smaller triangle is 100. The corresponding height right here of the larger one, we know this length is 5, so that would be 100 plus 5. And then a side of the smaller triangle we know is 15 right here, as it corresponds to the length that we're trying to find here, which we would call x. And we can simplify here. If we divide them both by 5, we would have 20 over 21. And we can cross multiply and get 20x is equal to 21 times 15, which is 315. And divide that by 20, and we get 15.75. But we would have to multiply that by 2 because we want this length right here. So that would be this length plus this length. And since those two are the same, 15.75, just multiply that by 2. And we have 31.5 centimeters.